Critical thinking, creative inquiry, and process-based learning are the foundations of a concept known as STEAM, a standard first brought to us by over 13 agencies, including the Department of Education, and later enhanced to include the arts thanks to the Rhode Island School of Design. It's more important than ever for students to be equipped with the knowledge and skills to solve tough problems, gather and evaluate evidence, and make sense of information. These are the types of skills students learn by combining science, technology, engineering, arts, and math, subjects collectively known as STEAM. Similar to broad terms like 21st century skills or hands-on learning, the meaning of STEM education isn't always easy to clarify for teachers. Yet there's an immense amount of interest in it due to the increased awareness in media, marketing, and even in retail. STEM itself isn't new. In fact, it was originally created in the late 90s as a method of nationally standardizing state science requirements as experts tried to formalize these science standards. It was very clear that in order for it to be effective, it needed to be more hands-on and include problem solving. 2 decades of product innovation later, there are now hundreds of options available. As more and more schools adapt their curriculum to STEM education and embrace new technologies to support it, it's helpful to look at STEM or STEAM solutions within the mindset that it isn't just about addressing one letter of the acronym at a time. These topics are woven together to ensure it's more about real-world application. For example, a student doing a physics experiment on speed would use technology to capture the data and math to analyze the results. A good STEAM solution will integrate the concepts of science, engineering, math, and art using the tools of technology, all while helping students to develop 21st century skills like collaboration, teamwork, critical thinking, problem solving, creativity, and imagination. Always remember that the products fitting within the STEM or STEAM solution may already have easily accessible lesson plans available to use within your curriculum. So make sure to check out each manufacturer's website for these free resources, and be sure to reach out to your IT provider for help with quoting classroom packs. Enough with the acronyms and tongue twisters. How about some examples of this initiative in action? We'll start with coding. The ability to write scripts for hardware and software applications was once something only attempted by the brave, and absolutely only ever done by DIY rigs from home or in a computer lab. Now, coding lessons can easily be taught and run on smartphones, tablets, and laptops, and it's everything from programming LED light boards, creating custom navigation paths for robots or drones, or even automating a big skyscraper build in Minecraft for education. In many cases, coding will incorporate science, technology, engineering, math, and even art. Speaking of art, for students of all ages, art can play a key role in developing and nurturing creativity and imagination. Supporting digital art in the STEM classroom has never been easier with the variety of dedicated graphics tablets or even standalone precision art pens on Windows, Apple, and Chrome devices. A great example here would be students learning fundamentals of designing by coding a website, creating the images for the site, and combining math to ensure that they are the most optimal resolution of pixels per inch or for the responsiveness of the display. What about 3D printing, makerspaces, and robotics? Do those check the STEM box? Yes, yes, and more yes. With the rise of one-to-one student device deployments, the need for dedicated computer labs has evolved into what's more commonly known as a makerspace for many schools. Makerspaces provide hands-on, creative ways to encourage students to design, experiment, build, and invent as they deeply engage in science, engineering, and tinkering. A makerspace is not solely a science lab, a wood shop, computer lab, or an art room. It may contain elements found in all of these spaces. Sound familiar? These spaces become fantastic ways to start working STEM into your school, either directly into the curriculum, through revolving special programs, or as part of an after-school program. In fact, the National After-School Association alone has a ton of great content available, from lesson plans known as STEM Gems to a full modular-based after-school tech toolkit. Real-world problem solving is at the heart of the STEM and STEAM initiative, preparing K12 students for college, career, and a lifetime of creative thinking. If your school is ready to take the next steps to integrate STEM and STEAM technology into your existing curriculum, contact your IT provider today.